So problem number 10, we want to take the limit of this function as x approaches negative infinity, but we want to find this algebraically if we can. Now I want to show you a little trick here. This is kind of fun. It's a fun thing to do. We can this is x squared over x squared, right? What if I were to do something like this? What if I were to multiply that by 1 over x squared, and whatever I do on the bottom I also have to do on the top? What if I were to do that? Times this whole thing. Now I've kind of skipped over this, but this is what we could do algebraically speaking. That makes this negative 12x squared over x squared plus 8x over x squared plus 9 over x squared. And then this becomes negative 15x squared over x squared plus 2x over x squared plus 8 over x squared. Now I'm really trying to prove to you that the answer is going to be negative 12 over negative 15. Well, algebraically speaking, what happens here and here? The x squareds cancel. Over here I've got 1x that cancels with one of these x's. And so in my numerator, and in the same thing here, I've got 1x here that cancels with one of these x's. So what happens is this whole function changes to negative 12 plus 8 over x plus 9 over x squared all over negative 15 plus 2 over x plus 8 over x squared. You don't have to. I just want to show you guys, just in case you're curious where the answer comes from. All right. Now, when I plug in infinity, I'm going to end up with negative 12 plus 8 over infinity plus 9 over infinity squared, if that's possible, plus 2 over infinity plus 8 over infinity squared.
Isn't it negative infinity?
Yeah, negative infinity. It doesn't matter. We put in negative infinity if you want.
So if you don't change it to that, you just plug it into the original?
Well, I'm going to show you the shortcut. Just kind of bear with me and then I'll show you the shortcut. You don't have to write all this out. So now, what are all those terms that I have over infinity going to approach? What are they equal to? 8 divided by infinity, or negative infinity, is equal to what? 0. So this goes to 0. 9 divided by infinity squared goes to 0. This goes to 0. This goes to 0. What am I left with? Negative 12 over 15. The negatives cancel. If I were to reduce that, what is that? That's the limit. I did that because I wanted to show you the behavior. What we've always said, and Mr. Adams has said this, I said, when you have a second degree polynomial over a second degree polynomial, and as we start to approach infinity or negative infinity, the behavior of the remaining terms aren't that important. They're not that significant. In other words, when we take the limit as something approaches infinity or negative infinity, we're really only concerned with the leading terms of the polynomials, because everything else goes to 0. Does that make sense? Do you guys see that now? So I've kind of glossed over that, and I wanted to prove that to you. So really what we're looking at is this. Negative 12 over x squared, or negative 12x squared over negative 15x squared. And then the x squareds cancel out, so we're really just looking at negative 12 over negative 15, or positive 4 over 5. So you could, when you see this problem, just if they're the same term. Now we'll do another one where this only works if the degrees of the polynomials are the same. I mean the not worrying about the stuff at the end, that works every time. well, let me do the next problem, okay? Do you guys see where I got the answer from?
Yeah.
Mr. Adams, I'm not gonna be able to do that, like where you make it smaller on my own during the test at all.
So what you would do is, this is what you're gonna do on the test, okay? When you get the test, and we'll make a completely different one, all right? So this is,
Can you just do the same one? Because I need to know how to do it.
okay. So then if I say the limit as x approaches negative infinity of negative 12x squared plus, what was it, 8x? 8x plus 9 all over negative 15x squared 2x plus 8. All right, now look at this. As I approach infinity, the constants aren't going to matter. Does it matter if I have infinity plus 9, does it matter? No. So we're not going to worry about that. If I approach infinity or negative infinity, if I add 8 to negative infinity, does it matter? No. No.
Is there a way to like graph it?
Yes. When if I go infinity over infinity, this term and this term, because we're squaring, we're really only, whenever we take an infinite, when we take a limit that approaches infinity, we really want to make sure, as long as they're written in descending order, we're only concerned with the leading terms. So the leading term is negative 12x squared, and the leading term here is negative 15x squared. So we could literally just ignore all this.
Is that because they're so small?
They're insignificant compared to infinity. Because when you start to square really big numbers, 1 million squared is going to be way bigger than this plus 9.
Alright, and then
And even if we added 8 million to it,
it would still be.
it's still 1 million squared. So at some point in time, as x gets really big, this stuff doesn't matter. It just goes away. So then what we look at is those two leading terms. Well, what do those two terms reduce down to? Yeah, because the x squareds cancel, and then the negatives cancel, and if you reduce it, it's just 5 or 4 over 5. And that's your limit. Well, let's do another one, because
Oh, I got it.
well, we've got one where they're not the same. So let's do another